All right, this is the next section we are covering. It is 6.6 called dividing polynomials. Divide polynomials. All right, so the last section was dividing monomials. Remember we said a monomial had a single term, no pluses and minuses. Well, a polynomial is multiple terms, so we have terms that are added or subtracted together. So just a quick recap on fraction addition. So if we have a divided by c plus b divided by c, notice that because they have a common denominator, they both have a denominator of c, that means we can directly add our numerators and share that same denominator. Well, the same is true if we want to split them apart. So say we started out with a binomial on the numerator here. We can break this apart as long as we keep the denominator intact. We can divide it into separate terms. So let's see what that looks like in algebra. Let's do an example. Let's go to red here. So let's say we have a binomial on top, 7y squared plus 21 divided by 7. So what we're going to do here is we're going to divide it using this concept right here. We're going to divide it. So we have to keep our denominator completely intact, which is easy since it's just a 7. 7y squared divided by 7 plus 21 over 7. So notice we split up the numerator here into two terms, but they both got that same denominator. So now the reason we want to do that is because we want to simplify each term. Notice that here we have a 7 over 7. Those will cancel out because they're just 1. So that will leave us with y squared for that first term. And here we have 21 divided by 7, which is just 3. So we can say y squared plus 3 will be the simplified version of this expression right here. All right, let's try another example. Let's say we've got, and let's write it differently. Remember I told you in the last section that we could always write, instead of that fraction bar, we can always use a division sign. Concept is exactly the same. Remember, whatever we're dividing by is going to be our denominator. So let's rewrite this as a rational term. So notice the 6x is the denominator, and both terms is going to get divided by that 6x. So again, we can break this guy apart. So that would be the 18x cubed divided by 6x minus the 36x squared over the 6x. Now you should be able to simplify these individually. Numerically, we have 18 divided by 6. That'll give us 3. And remember what to do when we have from the last section in dividing monomials, that if our bases are the same, all we have to do is subtract our exponents. His exponent is a 1. Remember, if it's not written, it's understood to be a 1. So x cubed divided by x will give us x squared. Just subtract those exponents. All right, our next term here, we have 36, numerically 36 divided by 6. So we have a minus. That's going to be minus 36 divided by 6 will give us a 6. And again, we're going to subtract our exponents because our bases are the same. So that will leave us just with an x. And we can leave it like that. All right, let's try another example. How about 25y squared minus 15y divided by negative 5? We'll throw a negative in there to try and see what happens. All right, again, we can simplify by dividing up the numerator. Just keep the denominator intact. So if we split them apart, we have 25y squared divided by negative 5. minus, because of this minus here, we're going to say minus 15y divided by negative 5. Remember, the denominator stays intact, so it was a negative before, so it stays a negative. So now we need to do some simplification. We have 25 divided by negative 5. That gives us negative 5. The y squared will just carry down because there's no y's in the denominator. Over here, notice that we have 15, but the 15 is negative because of the minus here. And we have a negative on the denominator. So we have a negative 15 divided by a negative 5. Remember that a negative divided by a negative is a positive. So that will give us plus 3. And again, the y just carries down since we have no y's in the denominator. All right, let's try one that's a little harder. How about we have this one here, 15x cubed y. We're going to add another variable in there. Minus 35x y squared, all divided by negative 5xy. All right, so let's simplify him by separating the numerator. I think I'm going to go down below because I don't have room beside it there. So if we break it apart by terms, we have 15x cubed y divided by, negative 5xy. So I lost my pen here. I kept my denominator intact when I split it apart. And then minus, because of this minus here, 35xy squared divided by, again, I need to keep that denominator intact so the negative will come across as well. All right, so we're going to simplify each term. Numerically, in my first term, I have 15 divided by negative 5. That's going to give me a negative 3. Then, what I'm going to do here is I'm going to combine my like terms. So notice that I have x cubed over x. From last section, we learned that we subtract those exponents, so that will give me x squared. What happens to our y's now? We have y to the first over y to the first. So we can look at that one of two ways. One way we could say 1 minus 1 is 0, y to the 0. Anything to the 0 power is 1. Or we could say y over y cancels out because that's 1. Either way, the y disappears from that first term. Okay, my next term here, I have a negative here and a negative here. So I have two negatives, which will give me that positive, and 35 divided by 5 will be 7. So we're going to say plus 7 because of the two negatives. Then we're going to have to simplify our variable. We've got x over x, again, just like those y's, they're going to simplify to a 1. And then we have y squared, and then y to the first on the bottom. So the 2 minus 1 will give us a 1, which will be y to the first power, but I don't need to put that 1 up there. It is understood. All right. That looks like the gist. So just a quick note, your WebAssign may ask you to divide some of these polynomials long division style. I will not ask you to do that on a quiz or on a test. As long as you can keep them, if you can do what we've done here today, that is all you need to do for this section.